Status network hypothesis. Modeling human status as a graph of relational utility and connection strength. Abstract. This paper develops the status network hypothesis, which proposes that human status can be modeled as a dynamic graph structure. Each individual node is characterized by two key variables: relational utility ranging from -1 to 1 and connection strength ranging from 0 to 1. Their product defines status as brightness in a spatial metaphor where nodes resemble stars of varying luminosity. Extending this analogy, planets represent nodes with reflective status, while black holes correspond to destructive or negative status nodes that absorb the brightness of others. Status radiates across the network over time, generating evolving fields of social luminosity. This framework distinguishes between subjective, relative, and aggregate, absolute network models, suggesting that social status is not static, but emerges from recursive evaluations of utility and connection strength. The hypothesis integrates insights from network theory, evolutionary psychology, and cosmological metaphor to conceptualize human social dynamics in spacetime. 1. Introduction. Status is a fundamental but elusive concept in human societies. Traditionally, it is understood as prestige, reputation, or social position. This paper advances the status network hypothesis, which seeks to formalize status as a measurable outcome of relational structure. Drawing from network science and evolutionary psychology, status is here modeled as a function of bilateral interactions mapped in spacetime. The cosmological metaphor of stars, planets, and black holes provides a framework for visualizing how status emerges and evolves. 2. Conceptual framework. Nodes represent entities, typically humans, but potentially also organizations or artificial agents. Edges denote perceived relationships, each weighted by two variables: relational utility and connection strength. Utility reflects the perceived benefit or harm of another node, -1 to 1, while connection strength captures the intensity or closeness of a tie, 0 to 1. The product defines bilateral status as perceived brightness. Individual perspectives yield subjective network, while aggregating these perspectives approximates an absolute network model. 3. The two variables. 3.1. Relational utility. Utility is defined as the extent to which one node perceives another as beneficial or harmful. A positive value indicates usefulness, trust, or contribution. A negative value indicates cost, harm, or reputation cost. 3.2. Connection strength. Connection strength denotes relational intensity, ranging from weak ties to strong, enduring bonds, while unilateral beliefs define initial perceptions. Bilateral averaging approximates more objective ties. 4. Status as brightness. Status is modeled as brightness, the product of utility and connection strength. Stars symbolize nodes with high positive status. Planets represent reflective nodes that shine only through proximity to brighter neighbors. Black holes embody negative nodes that absorb light and diminish surrounding brightness. Initial conditions, example genetic endowment, inherited capital, correspond to matter or mass, providing baseline potential for luminosity. 5. Temporal dynamics. Status is not static. Interactions function as information exchanges that update belief. Cooperation, once demonstrated, enhances it. Over time, status signals propagate like radiation, producing evolving patterns of luminosity. The fourth dimension, time, enables analysis of trajectories, growth, decline, or collapse of status within a network. 6. Subjective and absolute models. Two perspectives are distinguished. The subjective relative model reflects each individual's personal evaluation of utilities and time. The absolute global model emerges as the averaged aggregation of all subjective networks. While the absolute model remains an approximation, its reliability increases with network size, akin to collective intelligence phenomena. Malone, 2008. 7. Implication. It parallels network centrality metrics like page rank, yet adds dimensions of negativity and reflection. It resonates with Dawkins' 1978 description of humans as survival machines, biological nodes within larger structures, and with evolutionary psychology accounts of cooperation and competition. Potential applications include organizational analysis, reputation systems, and simulations of social dynamics over time. 8. Discussion. The cosmological metaphor offers both clarity and risk. While stars and black holes provide intuitive images, they may oversimplify social complexity. Future research should formalize equations for network brightness and model transitions from reflective to emissive nodes, and simulate how negative ties reshape fields of social status. Longitudinal studies may illuminate how networks reorganize after reputational shocks. 9. Conclusion. Status emerges from the interplay of relational utility and connection strength, propagating across networks as dynamic brightness. The status network hypothesis situates status as both individual and collective, subjective and absolute, momentary and evolved. By conceptualizing status as luminosity in spacetime, the framework invites new approaches to modeling prestige, reputation, and cooperation. Acknowledgement. This paper was developed with the assistance of AI-based tools. The responsibility for the ideas and conclusions rests with the author. References. Barabasi linked The New Science of Network. Persoid. Dawkins, The Selfish Gene, Oxford University Press. Granovetter, The Strength of Weak Ties, American Journal of Sociology. Malone, Superminds, The Surprising Power of People and Computers Thinking Together. Little Brown Spark. Watts, 6 Degrees, The Science of a Connected Age. Norton and Company.